lesson 0.3a. Okay, for example 1 part A, we have to write the polynomial in standard form. So standard form means you start with the variables with the highest exponent and you go down in descending order. So there's the highest exponent. So we have 25y squared. This is y to the first. So we have minus y. And this is essentially y to the 0th power. We just have this constant here, so the constant comes at the end, plus 1. All right, so that's part A. Part B, identify the degree and leading coefficient. The degree, abbreviation here, the degree is the value of the highest exponent. So that's right here, and that's 2. And the leading coefficient is the number in front of the variable with the highest degree. So that'll be 25. Part C, state whether the polynomial is a monomial, binomial, or trinomial. Well, how many terms make up this polynomial? The polynomial is simplified as much as it could possibly be. And so we have 1, 2, 3 terms, which makes it a trinomial. All right, and that answers all the parts to example 1. Next example. Determine whether the expression is a polynomial. If so, write the polynomial in standard form. Note, polynomials have variable exponents that are natural numbers. Natural numbers are positive whole numbers. So right away, when you look at this expression here, it has a variable whose exponent is negative, which is not a natural number. So right away, your answer is no. 1 of the exponents, is not natural. All right, on to the next example. Perform the operation and write the result in standard form. Okay, there's a negative 1 here that we have to distribute to each part of this binomial. So we have negative 5x squared plus 1. Don't forget plus 1. Some students forget to distribute and they write minus 1. Once again, we have to distribute the negative here. Be careful with the negatives. 50% of the time, I'd say that's what messes up a student. All right, so we have plus 3x squared, then we have minus 5. All right, and now we're going to simplify. So we have negative 5x squared plus 3x squared, which is negative 2x squared, and 1 minus 5, which is negative 4. And that's all we could do. Done. Next example. Okay, multiply or find the special product. All right, we're multiplying 2 binomials here. So we have to FOIL, first, outer, inner, last. All right, so we have x squared plus 10x minus 5x minus 50. All right, combine like terms, and we have x squared plus 5x minus 50. Done with that. For the next one, here is the most classic mistake I see students make every year. Oops. All right, they do that. All right, now why does that not work? Okay, since there's a plus sign here, you can't distribute that exponent. Does not work. If you have 4x times 5, distributing that exponent, cool, that would work. But since there's a plus here, no can do. So what do you do? Get that away. What do you do? You have to expand 4x plus 5 times 4x plus 5. So don't do this. All right, so we have to FOIL once again, and we get 16x squared plus 20x plus 20x plus 25. And we have 16x squared, combined like terms, we have plus 40x, and we have plus 25. Done. Okay, for the third example, going to the next page, I'm going to show you 2 different ways to do this problem. All right, first thing we're going to do is just expand. 3x plus 2y times 3x plus 2y times 3x plus 2y. All right. Then we get, by foiling the first two binomials, 9x squared plus 6xy plus 6xy plus 4y squared times 3x plus 2y. Then we simplify. We have 9x squared plus 12xy plus 4y squared times 3x plus 2y. All right, then we have to multiply again. And yes, it's a bit tedious, but it's simple. Just take your time. Be careful with your work and the variables. Don't mix up the x's and the y's. And we get 27 x squared plus 36 x squared y. Then we get plus 12 x y squared. We have plus 18x squared y plus 24 xy squared plus 8y cubed. Okay, now combining like terms, our final answer is 27x cubed plus 54 x squared y plus 36xy squared plus 8y cubed. All right, let me show you a different way to do this problem. Okay, for the second method, we will use Pascal's triangle. Now, how exactly does that work? Start with the 1. 1's on the bottom. 1 and 1 adds up to 2. 1's on the side. 1 and 2 adds up to 3. 2 and 1 adds up to 3. 1 and 1 on the side. 1 and 3 adds up to 4. 3 and 3 adds up to 6. 3 and 1 adds up to 4. 1 and 1 on the side. Okay, now how does this apply? Well, a plus b to the 0th power, that's simply 1. Here we have a plus b to the 1st power. All right, our coefficients for both a and b are 1. Then we have a plus b to the 2nd power. Our coefficients would be 1, 2, 1. A plus b to the 3rd. A plus b to the 4th. All right, let's see how this works out now. We are working with a cube in this problem, so we're working with these coefficients here. So here's the general binomial, a plus b, that's being cubed in this case. All right, and when you do that, this is how it all breaks apart in the end, when you multiply it all out. You're going to have a to the power of 3, a to the 2nd power, a to the 1st power, then a to the 0th power. You're going to start with b to the 0th power, then b to the 1st, b to the 2nd, b to the 3rd. Then you have the coefficients, 1, 3, 3, 1. 1, 3, 3, 1. And then you're just adding them all up. And those signs may change depending on what the values of a and b are. In this case, a is 3x. Okay, that's your a. And b is 2y. All right. And since both of these values here are positive, we're going to end up with nothing but pluses in the end. But if this was negative here, we may end up with negatives in our final answer. All right, so let's replace the a's with 3x's and the b's with 2y's. So 3x to the 3rd, and we have 2y to the 0th power. Hopefully I could squeeze this all in here. 3x to the 2nd, and 2y to the 1st, plus a to the 1st. I think I'm going to do it. 2y to the 2nd, plus 1 times a, 3x to the 0th power, and b, which is 2y to the 3rd. All right, we simplify it, we polish it all up, And we get this. 27 x cubed plus 54 x squared times y plus 36 xy squared plus 8y cubed. Now, both methods seem to take the same amount of time, but once you go higher in power, I would say the Pascal's triangle method is more efficient. So you choose which one you want to use. All right, find a polynomial that represents the total number of square feet for the floor plan shown in the figure. Okay, so got to figure out the area of this space. Now, what is this length? All right, very common mistake students make is they write 18 x squared, all right, or something like that. But it's x plus 18. So it's going to be 2x plus 18. Make sure you don't do that. I see that very often. Don't do that. All right, x plus x is 2x. X plus x is not x squared. Okay, I also see students write this. Don't do that. X plus x is 2x. All right, 2x plus 18. The other side is simply x plus 14. All right, so we multiply those two lengths because we're just trying to find the area. Base times height, or length times width. All right, we're going to have to FOIL. We have 2x squared plus 18x plus 28x plus 252. So we have 2x squared plus 46x plus 252. And you could write square feet. Okay, I'm not picky about that, but that's your final answer. All right, if you happen not to put that on a test, I'm not going to ding you. I mean, if you could do this much, you know what you're doing. But if you could put that, make sure to include that. That's nice. But once again, I'm not going to ding you. All right, start lesson 0.3a homework, or the assignment, as seen at the bottom of the webpage.